Hey guys, welcome back to Akacademy once again. So in this particular lecture, we are going to see the reactions of the carbene, right? So first of all, let's understand first reaction, which is also example of Simon Smith reaction, right? And we have already discussed a lot of things about this one. Now let's understand. So here what we will have, if we have alkene, so in that case, if we are using this CHBr3, right? If we are using this CHBr3 and here we have the base. So what this base will do, just like the Rearrangement reaction, so this hydrogen will get abstracted and here the formation of CBr and here Br. Such kind of carbene will be formed in this case and this carbene will get added over here, right? Because this is Z type of alkene, so here the product form will be cis, because we have discussed that this reaction, Simon Smith reaction, is a stereospecific type of reaction, right? Got it? But the thing is, this, if this is stereo specific, so only if we have singlet carbene, then in that case only this will be the stereo specific reaction. Otherwise this won't be a stereo specific reaction in case, if suppose if we have the triplet carbene. And how this will happen, let's understand. If suppose if I take one alkene, let's say we have this one alkene only, right? If we have something like this only, this one alkene, whatever we have over here, and if suppose if we have the triplet carbene, so here we have this, I'm considering this as, over here we have this H and here we have this H, right? But the thing is, here the spin of these two electron will be same actually, right? If the spin of these two electron will be same, so how we can proceed with this one? If we have the triplet carbene, so here suppose if the radicals are formed, right? If I convert it into the like this, so here we have this spin like this, and here one electron will have the different spin like this. And here what we know, in the triplet carbene the spin of this electron will be same in this case. So first, in the first step, what will happen, this will come one carbon, which you can see over here, that is going to combine with this one, right? If this will combine with this one, so what will happen, so here if suppose if this is combining with this one, so here we can have this, I can write it like this methyl, suppose this methyl is over here, this methyl is above the plane like this, right? Over here as well. So if this methyl is over here, so what will happen in the next step, here we here one this CH3 like this CH3 will get added over here, right? And here we also have this H like this. Got it? After, in the next step, what can happen over here, in the next step we can have some, here we have one electron, but we know that here if both spins are same actually, so that is not going to form over here, right? If both the spins are same, so what can happen over here, I can write it like this. So suppose here CH3 is above the plane and hydrogens are below the plane like this, right? And here what we had this CH2 molecule, so we have this CH2 as a triplet carbene, right? And here what we will have, here we have one electron over spin like this and one electron spin like this. And after this what will happen, if this is combining with the CH2, so something like this will be formed, and here we will have like this, right? The valency of the carbon is maintained over here. And if suppose if the next one is combining, so in that case what is going to happen, if the next one will combine, so in that case we will have actually, so this has to be rotated. If this will rotate, so we will have here our one hydrogen, here one hydrogen is our above, sorry, below the plane, and this methyl is above the plane, right? So if this will rotate, so this methyl which you can see over here, so that will come below the plane, and the hydrogens which you are seeing over here, so that will come over here, and this is our hydrogen and this is our methyl, right? And here the groups which got added over here, right? Sorry, here this is not CH3 but it will be CH2 only, CH2 like this, right? One electron is over here, but the spin of this CH2 is like this only. So after the rotation a spin will be changed, right? Here the spin of this CH2 is like this, and after the rotation the spin will change, and then only this can combine with this one. But here what you can observe, actually one methyl is above the plane and one methyl is below the plane. Here we had both the methyls above the plane, right? So here the trans product will be formed like this. Trans product will be formed. So I can write it like this, and here we have this methyl group, and here what we have one hydrogen, and here what we have this methyl group, and here what we have this hydrogen. So this is trans product, right? But in case of cis, so we had something like this. In case of cis, if suppose this has to be combined, so in case of cis we will have something like this. Hydrogen will be over below the plane, and methyl will be above the plane, and here also methyl will be above the plane and hydrogen will be below the plane. So this is cis product and this is trans product. So suppose if we are using the triplet carbene, so in that case cis plus trans will be formed. So reaction is not actually the stereo specific as we have in case of singlet carbene. But in case of singlet carbene, so the addition which you can see that proceeds like this, right? Because the spin of this carbene is actually different one. Both the electrons will have different spin. So that's why it is very easy to combine with this one and give this product. And in case of triplet, so this will rotate and trans product will also be formed. So this is like that only. Now let's take another example. If I take this one, so what I had told you, like here in case of this one, right? In case of this one, what will happen? Here the oxygen which you are seeing over here, right? This will, the whatever the stereochemistry of this oxygen will be, in that like that only the carbene will get added over here. So the final product formed here will be something like this. If I say, so this oxygen is below the plane, so here the carbene will get added below the plane only, like this, right? Here we have this oxygen and this oxygen, and let's take like this. And here in this case the oxygen is above the plane, so in this case actually the carbene will get added like this only, right? This we have discussed in the Simon-Smith reaction. And here if the stereochemistry of this cyclopropane will be according to this oxygen whatever is just next to this cyclopropane, right? So this is the thing which you should know in this case, and such kind of cyclopropanation reactions are actually the Simon-Smith reaction or the Simon-Smith reaction, whatever you call it. Now let's take the different one. Now suppose if we have something like this, we are talking in case of cyclopropanation only, and now let's take another examples. What if we proceed the reaction in presence of a Lewis acid, right? So in that case you have to find out the, actually first of all you have to find out the configuration of the chiral carbon in this case. So here the chiral carbon which you can see over here, here we have this chiral carbon and this chiral carbon, and in this case what is going to happen, this chiral carbon is having configuration as R, and if this chiral carbon has configuration as R, so what will happen in this case, because this is a Lewis acid, so what will happen, this will definitely, the product whatever you will have here, the configuration of this one, the configuration of this carbon and this carbon whatever you can see over here, because here what is going to happen, this is asymmetric cyclopropanation in presence of Lewis acid. So what will be the configuration of this carbon, so this carbon will have configuration as S and this carbon will have configuration as S, because the R phase in this case will be blocked and the product is not, will be R over here if we are using the Lewis acid. So in that case please remember, if in case if you see a Simon-Smith reaction and here they have also been given the Lewis acid, so in that case the first thing which you have to do is to find out the configuration of the chiral carbon in this case. So here what we can see, the chiral carbon is R and R, so in this case the product side the configuration will be S and S only, right? R won't get formed. And the enantiomer axis you can see here what we have, the 93%, here the 98% product is formed, and in this 98% we have the 93% as S and S. It's not like that R won't be get formed, R will be there, but the major product in organic chemistry we actually talk about the major product. So here the major products will be only S and S, and that will be 93% enantiomeric axis will be over here. Likewise this, if I take this one, so here what we have, here we have this again, here again we have this Lewis acid, so this is same one but here the configuration is different, here we have R, S and S. So in that case we have two alkene over here, right? Two double bond present in this case, and both will get added like this. There the cyclopropanation will takes place and the product form will be 89% and 97% enantiomeric axis will be formed. And here what we have, the configuration as S and S. So here the configuration will be R, R, and this R, R, like this only, right? So this will be the product. I hope you understood up to this much. Now let's take different example, and in this case we are going to see actually what will happen. If I take this one, suppose if we have this one, this example I am taking, right? If suppose if we have this example, so in this case what will happen? If we have this, if I take this example, so in this case actually the thing is, if the reaction is proceeding in presence of this copper sulfate CuSO4, right? So here what will happen, this N2 which you can see over here, so that is going to form a carbene here, right? So carbene will be formed in this case, and here we will have 2 electrons, and this N2 will be removed. After this what will happen, please understand. So this N2 whatever we have over here, actually this is attached with CO2Me, right? This is an ester group, and this here in case of, if suppose here the cyclization is taking place, so actually 5-membered rings will be more preferred. If there is not possibility of any 5-membered ring, then only we will go for the 6-membered ring. Otherwise whenever we have the carbene, so in that case we will proceed for the 5-membered cyclic ring, right? So the carbene will get formed over here. So if the carbene will get formed over here, so that will attack at this carbon, right, or this carbon, right? So here what you can see, if I try to find out the product, so in that case this carbene which you can see over here, actually that will get attached with this one, right? And cyclopropanation reaction will take place over here. If the cyclopropanation reaction will take place, so please understand what will be the stereochemistry over here. So here what you can see, the stereochemistry, here we have this methyl group. So this methyl is basically this one, right, this red line, and this methyl group. And here what we have, this methyl, you can see this methyl is trans with this one, this methyl is trans with this ring, right? So here if suppose if we have this CO2Me and here the hydrogen we have, so what you can see, if this is in the plane, so this methyl which is present over here, actually this methyl should be trans to this one. If the cyclopropanation is taking place, so in that case, so this bond, this CH3 which you can see, that will come out of the plane, right? And that will be just like the CO2Me, and CO2Me and this methyl will be in the same plane, and the hydrogen will be in the same plane, because now you can see, because this is trans with this one, right? And here in this case only this will be the trans with this one, and then this will be the product, right? And now let's take example of the insertion reaction, and carbene can also go with the insertion reaction. And now let's see how we can have. Suppose if we have R, here we have this C, and here if suppose again we have this R, right? If I take the methane as the example, so in this case if I am taking the methane as the example, so what can happen, here the carbene can be actually inserted between this carbon and hydrogen. So we can have this CH3, and here we can have this C, right? And here we can have this R, one R over here, and here what we can have, again one R and this one H. So you can see the carbene which we have over here, actually this will get inserted between this carbon and hydrogen, right? So that's why we are getting this. This is the carbene part, sorry, RCR is the carbene part, and this hydrogen is from this methane. So this kind of reactions are actually called as the insertion reaction, right? And what about the mechanism and how the mechanism proceeds? Actually, if I talk about this one, so here the product form will be CH3 and this H, right? The bond will break, and this CH3 will combine with this CR2. If I say, here we have 2 electrons, right? If this will, first of all, this will combine with this one. So here in the first step, so we will have CH3 and this CR2, and this is the first step. And in the second step, what will happen? Here we will have this CH3, and here we have this CR2 and this hydrogen radical, right? So they both will combine, and the product form will be CH3 CR2H, like this, right? So this will be the process whatever I am talking about. So this is the first example. Now let's take the different one. If suppose we have this one, so here what we have, the N2 group, right? N2 group. So if I'm I am providing it photon, so what will happen here, the carbene will be formed. If the carbene is getting formed, so suppose if we are taking the cyclohexane, what I told you like this, so here we have the cyclohexane, so hydrogen actually what you can see in this mechanism, so this is, first of all this hydrogen will come over here and this will be combined with this one, so here the we will have this CH2 and the cyclohexane ring will be introduced over here, and this is the example of the insertion reaction, right? I hope you understood up to this much. Now let's take the different example and proceed with this reactions. Now in the next example we have this such kind of substrate, and what will happen, let's see. So here what we have, this part, this which you can see over here, so we are providing H nu, right, and this is a solvent over here, so here the formation of carbene will take place over here, so here we will have carbene will be formed over here only, right, and double bond will come over here. After this we have this carbene, right, just like the Wolff rearrangement reaction what we had discussed in the Wolff rearrangement, here we had, sorry, here what we had R C double bond O, and here we have this CH and this carbene, so this R migrates with this bond over here and the formation of ketene takes place actually, right. So here what we had, here we had this R will migrate over here, so this will become what, RCH double bond C double bond O, ketene formation will take place, right. So here the same thing will happen, this bridget carbon which you can see, this will migrate over here and the product will be formed like this, pay attention. So here we will have this much, and after this we will have double bond C double bond O like this. After this we have this MEOH, so OMe which we have over here, so that is going to attack on this one and we can have product, sorry not this one, but we will have CO2Me will be the product, right, and hydrogen will, this negative, first of all this will attack over here, so either this this can become O minus, right. After this when this will come over here, so this will come back to its position and here the negative charge will come, right. If suppose the negative charge will come over here, so what can happen in the next step, if the negative charge will come over here, so after that the process will be this H which is present over here, so that can combine with this one, and here the final product we will have something like this only, right. Now let's take the different one and now let's try to solve this one. So what is happening in this case actually, let's see. Here we have this CO2Me and we are treating with this KOH, and we have this COCl2 and we have this CH2N2 over here, right. If suppose if we have something like this example, then what we can do actually in this case, so here here what we have, here we have this C double bond O and we have this OMe, right, and in this case the product form will be something like this. Let's take this one and this, and we will have C double bond O, and here we will have double bond N2, and this is what below the plane, so I should write like this, and this double bond and this one, right. First of all what we are doing, we have this KOH and we have this COCl2 and we have this CH2N2, so that what that will do, we have this C double bond OMe like this, right. So what will happen, this CH2N2 which you can see, so that will attack on this carbonyl carbon and OMe will be actually getting removed over here, and we will have here CH and this N2, right. So that will be formed. After this we are treating it with AzOBr, right, and if we are treating it with AzOBr, and here let's take one as MEOH, so what will happen in this case, so this is going to form something like this CO2Me, and here like this. So if we have this AgOBr, right, so here the radical formation will be over here, so radical will be formed over here, right. Once the radical will be formed here over here, so what will happen in the next step, if we have this MEOH, right, if we have this MEOH and the radical is getting formed over here, if the radical we have over here, so this group which you can see over here, so this will migrate over here. Once this group will migrate over here, so the formation of ketene will take place. So once the formation of ketene will take place, and we have this MEOH, that again this MEOH will attack like this. In this case, whatever we have, so this MEOH will attack over here, and that is going to form this product which you can see in this case, right? So this is the process actually how this will takes place, right? But the thing is actually what happens, if suppose if we have alpha diazoketone, right, let's take, and this reaction is actually called as Arndt-Eistert chain extension reaction, right? So now let's take what we have actually, if suppose if we have RC double bond O, and here what we have CH and double bond N2 like this. If you see something like this, what happens, if we have higher temperature, in this case if I take the higher temperature, so this can undergo actually RC double bond O over here, and here what we have, here the ketene for carbene formation. If suppose if I am saying that the carbene formation is taking place in this case, but the carbene which is formed over here, actually that will combine with its molecule, and that is going to form a compound like this. Here we will have RC double bond O, and here we have this CH double bond CH, and here we have C double bond O and R, right? So this will actually combine with itself, and that is going to form a alkene, right? Alkene with this dicarbonyl group. But if suppose if I have to proceed with this reaction at the low temperature, right, so what I can do, so in that case actually we use Ag2O, right? If we use Ag2O, so this reaction can be proceed at the low temperature, and this reaction is actually called as then this one, Arndt-Eistert chain extension reaction, right? If let's take example of acid, so if we have RC double bond OH, and after this what I can do, if I am treating with if I am converting it with RC double bond O, here Cl, right, this can be converted into the chlorinating agent such as SOCl2 like this, right? So if we have this one, after this what can happen, after this I can very easily introduce here CH2N2 group like this, right? CHN2, here what we will have RC double bond O, and here we can have easily RCHN2 group in this case, right? And this reaction if I treat it with Az2O, so again same like whatever the steps I have taken over here, so that can takes place, right? So in this case what I want to tell you actually, if suppose if we have the substrate like the esters we have over here, or we have the substrate like the carboxylic acid, right? So that is a name reaction. Here that important name reaction is this one, right? This name reaction. So in case of carbene we have the one name reaction which is called it Arndt-Eistert chain extension reaction, and the second one is we have the Wolff rearrangement which we discussed already, right? And that is also very much easy to understand. Got it? So there are basically two major name reactions. So first of all what we had, this Wolff rearrangement and this Arndt-Eistert, right? And also we have discussed Simon-Smith or Simon-Smith reaction and Remer-Timmer reaction. So these are reactions are actually based on the carbene formation, right? So now let's take the different example and let's see what will happen in that case. Now suppose if we are taking the alcohol, so in that case how the insertion reaction will proceed. We are talking about the insertion reaction, so this is the one example. So we have this carbene. This carbene will attack on this oxygen. So oxygen will provide its one electron pair. So here oxygen will have positive charge and it will have negative charge. So after that this will abstract the proton from here, and this bond will shift, and the formation of ether will take place like this. Got it? Now let's come to the different example. If suppose if we have such kind of example, right? Here what we are doing, here we have this hydrogen and this position, right? This position, at this position we have N2 group. So after this what will happen, if you are treating with rhodium like metals and all, right, carbenoid formation. So if we are treating with this one, so here what will happen, the carbenoid will be formed, or we can say the carbene will be formed at this position, right? And after this carbene will actually abstract the proton from here, because this is what acidic proton, and this will abstract this one, and that is going to form a ring, and the 5-membered ring will be more preferred, as I have told you, unless and until there is possibility of 6-membered. In 6-membered actually rings are not much preferred. The first priority which you have to give in the carbene reactions, the 5-membered. After this, if the 5-membered is not given in the option and all, then only you have to see for the 6-membered, right? In suppose in the heterocyclic and all, oxygen and nitrogen, such kind of, actually if the elements are introduced into this one, and in that case the 5-membered ring are not proceeding, so then only you have to proceed for the 6-membered. Otherwise everywhere you will see that 5-membered rings are more preferred, right? Now let's take one more example. So we have this one, and after this what we will have, so this RH2 OAC like this, right? And after this what can happen, the carbene will be formed at this position. If the carbene will be formed at this position, so what can happen, actually like this, the carbene will be formed at this position. After this we have this sulfur, right, the sulfur, and after this what will happen, this sulfur will donate its electron and the negative charge will come, and if I treat with this, treat it with this benzaldehyde, if I treat it with this benzaldehyde, so in that case the product form will be something like this negative charge which you can see over here, that will attack on this carbonyl one, right? So this negative charge will attack on this carbonyl one, and after this what will happen, this oxygen which you can see over here, and that will again combine with this pH, right? So we will have something like this will be formed, and one phenyl will be above the plane and one phenyl will be below the plane over here, right? So this is the one example. Now let's take the different one. So what we have here, suppose if we have such kind of carbene like this, here double bond is already over here, and after this what will happen, so 5-membered ring will be preferred, so this hydrogen is active hydrogen, so that will going to form such kind of reagent, and this is example of insertion reaction. Now let's go for this one. So here what we have, here also we have one active hydrogen like this, and if we are treating with N2CH-SiMe3 and butyl lithium, right? So here what will happen, this will going to introduce N2 group over here, and if the N2 group will be introduced over here, so formation of carbene will take place, and this carbene will actually abstract this active hydrogen, and this hydrogen will going to form the 5-membered cyclic ring. So this will be the process in this case, right? Now let's go for the different one. And now we have actually come over here, but before that let me explain you one more reaction, and that is a kind of ring expansion reaction, right? So what happens in case of ring expansion reaction, and we have saw the example of this one in the Rearrangement case when we were discussing about the Rearrangement reaction. So we had seen the example like this only over there, right? So what will happen, if suppose if this is I am treating with this CHCl3 and we have the one base like KOH and all, right? So what will happen, the carbene formation will take place over here, and this carbene will actually get added with this one. Here we will have one, sorry, not over here, but here this Cl and this Cl, right? So this is what, this will be quite more unstable over here. So this bond which you can see, this will shift over here. So if this is shifting over here, so what is going to happen, the hydrogen which we have over here, so this one hydrogen, so this will shift over here, and this one Cl will be removed from here, right? And here the formation of product like this will take place. We have already discussed about this reaction, and if you want to know much about this, so go and watch the, so here we will have Cl at this position, right? So go and watch the Rearrangement reaction, you will understand. There we had discussed about this one example, this one nitrogen is present over here, right, like this. So in that case we were getting the, here this 5-membered nitrogen ring was getting converted into the 6-membered nitrogen ring, right? So this is the example. So now it's time to solve some previous year questions, and now let's see some previous year question, and this video is quite long, so we are going to solve the previous year question in the next video, and thanks for watching this video.